If you could build an AI agent that checks your competitors every morning, collects their pricing, tracks product updates, monitors new landing pages, and summarizes everything automatically, that's exactly what I'm building today. But there's one problem almost every AI scraping project runs into. Eventually, the websites stop letting you in. So today, I'll build the entire workflow from scratch, show you where it breaks, and then fix it. Today, I'm building a competitor research agent. The workflow is pretty straightforward. First, we'll give the scraper a list of pages we want to monitor. Then it will visit each page automatically. From every product, it will collect the product name, price, availability, and description. Once everything has been collected, we'll save it into a spreadsheet. Finally, we'll use Claude to summarize the results into something that's actually useful instead of manually reading hundreds of rows of data. For this demo, I'm using a public practice website that's designed for learning web scraping. The exact same workflow can later be adapted for competitor research, price monitoring, or market analysis on publicly accessible websites. Let's start building it. Building the scraper, the first thing I'll do is import a few libraries. We'll use requests to download web pages from the internet, then view is full to read and navigate through the HTML, and finally pandas, which will help us organize all of our scrape data into a spreadsheet. Next, I'll define the website I want to scrape. In this example, it's a public demo website with multiple pages of products. I'll also define how many pages the scraper should visit. Right now, it's just a range of pages, but in a real project, this could easily become a list of competitor websites. Before writing the scraper itself, let's inspect the website. This is one of the most important steps in any web scraping project. Every website has its own HTML structure, so we first need to identify where the information actually lives. Looking through the page, I can see that every product is stored inside its own product card. Inside each card, I can find the product title, the price, and the availability. One thing you'll notice is that the product description isn't actually on this page, it's inside each individual product page. That means the scraper will need to visit every product separately before collecting the description. This becomes important later because every additional request increases the total number of requests we're sending. Now let's write our first function. This function visits an individual product page and extracts the description. If a description exists, we'll return it. Otherwise, we'll simply return an empty string. Next comes the main scraping function. First, it downloads the page. Then ViewBeautiful parses the HTML. Now we loop through every product on that page. For each one, we extract the title, the price, and the availability. Then we follow the product link to grab the description. Finally, we store everything inside a Python dictionary. Once we've processed every product on the page, the function returns the complete list. Now let's build the main loop. This simply goes through every page we defined earlier, runs the scraper, collects all of the products, and stores everything inside one large list. When the scraping finishes, Pandas converts everything into a data frame. Then we export the results into a CSV file with a single line of code. Let's run it. The scraper visits every page, downloads each product, collects all the information, and generates a clean spreadsheet. At this point, we've successfully built a working competitor research scraper. So where does the problem begin? The scaling problem. The problem isn't scraping 3 pages. The problem starts when you scale. Instead of scraping a handful of pages, let's increase that number dramatically. Now the scraper is making far more requests, and remember, every single product requires an additional request just to collect its description. That means the total number of requests grows much faster than you might expect. Eventually, some websites begin responding more slowly. Others start returning errors. Some block repeated requests coming from the same IP address. The scraper itself isn't broken, the parsing logic still works perfectly, the AI isn't the issue either. The bottleneck is the network. And that's the challenge almost every large scraping project eventually runs into. Adding DataImpulse instead of rebuilding my scraper, I'm only going to change how it connects to the internet. Inside the DataImpulse dashboard, I'll create a residential proxy, copy the credentials, then add them into my Python project. The nice part is that almost none of the scraper itself changes. The parsing logic stays exactly the same. The functions stay exactly the same. The only thing I'm changing is how my requests are sent. Now every request is routed through residential IP addresses instead of always using my own connection. I also added a simple retry system. If one request fails, the scraper automatically retries before giving up. That makes the workflow much more reliable when scraping large numbers of pages. DataImpulse provides access to more than 90 million residential IPs across more than 195 locations. Depending on your workflow, you can choose rotating sessions if you want a fresh IP on every request, or sticky sessions if you need to keep the same connection throughout a longer browsing session. Another thing I like is the pricing. Instead of locking you into a monthly subscription, it's completely pay as you go. You only pay for the traffic you actually use. Your traffic never expires, and with a minimum deposit of just $5, it's easy to test your workflow before scaling it. Now let's run the exact same scraper again. This time the request completes successfully. The products are collected, the spreadsheet is generated, and the workflow finishes without changing the scraper itself. Results and city, let's open the finished spreadsheet. Here we have every product we collected, the product name, the price, the availability, the description, and the source page where it came from. Now, instead of manually reading through hundreds of rows, I'll pass the data into Claude to generate a quick summary. Within a few seconds, I have a clean overview of everything the scraper collected. And that's exactly the workflow I wanted to build, a competitor research agent that automatically gathers information, organizes it into a spreadsheet, and prepares it for AI analysis. If you're building your own AI agents, web automation, or competitor research workflows, I'll leave the DataImpulse link in the description below. Residential proxy starts at just $1 per gigabyte, and because it's pay as you go with no subscription, you only pay for the traffic you use. Your traffic never expires, and you can get started with a minimum deposit of just $5, making it an easy way to test your own automation projects before scaling them. Let me know what kind of AI agent you're building next. Thanks for watching, and I'll see you in the next video.